Welcome. Today we're talking about properties of real numbers. Now, properties of real numbers are really the reasons that we can do the things we can do. And if anybody ever asks us, why did you do that? We can say, this property states that it's okay. So today's lesson is going to talk all about what are the properties that you need to know and why do we need to use them. First one I want to start with is very basic. So for every real number, A, B, and C, they can be any number whatsoever. We're going to start with the commutative property of addition. Now, commutative property of addition basically says, I'm going to start with A plus B. If I have some number plus another number, the commutative property allows me, after the commutative property is applied, to switch the order of those. So I can write the same A plus B as B plus A. We can just switch that order. So if I have 3 plus 7, 3 plus 7 equals 7 plus 3. It's the same thing. They both equal 10, so why can't I add in that order? Now subtraction, on the other hand, you can't do that. If I went 3 minus 7, that's going to be a negative 4, where 7 minus 3 is positive. So addition, you have the commutative property. We also have a commutative property of multiplication. Commutative property of multiplication says that if I have any numbers times each other, I can flip the order. 3 times 7 is the same thing of 7 times 3. Commutative property of multiplication. Notice how, depending on the operation, we write of addition or of multiplication, so we know specifically what we are commuting, because subtraction and division, you cannot commute. The associative property. Associative property of addition basically affects the order. So A plus B plus C equals A plus B plus C. Notice the order doesn't change, but what we do first does. So example, if I had 6 plus 4, that's 10. So 6 plus 4 is 10. 10 plus 5 is 15. Likewise, if I added the back two together first, 4 plus 5 is 9. 6 plus 9 is also 15. Both of them give me the exact same answer. Associative property of addition, because we're adding these. We can do the same thing with multiplication. So multiplication, you can multiply in any order. Again, a thing to look for when you're trying to identify what property. Notice the first three numbers don't change the order. The A, the B, and the C is the same before and after A and the B and the C. It's the parentheses that switch. So 6 times 4 is 24. 24 times 5 is 120. Much like if I will go, and it might be even easier to think this way, 4 times 5 is 20. 20 times 6 is also 120. They both equal the exact same answer. Associative property of multiplication. Moving on, we have what's called the identity property of addition. Now, the identity is what can I do to something that won't change it. In this case, the identity for adding is 0. So I can go A plus 0, and it's going to stay A. It's not going to change it at all. I can add 0 all day long, and it's going to stay that same value. If I had 9 and I add 0 to it, it still stays 9. That's the identity property of addition. Identity property of multiplication is A times 1. Now, it's a little different with multiplying. You can multiply times 1 all day long without having it change. So A times 1 is still A. If I had 6 times 1, 6 times 1 is still 6. Nothing changes. Identity property of multiplication. The identity for multiplying is 1. Now, the inverse property of addition, the inverse, for every A, there's an additive inverse such that it's a negative A. Basically, whatever number I have, the opposite, if I add them together, if I add the opposite, it'll equal my identity. My identity, remember, for addition was 0. So 5 plus a negative 5 equals 0. 0 is my identity. So I'm adding two opposites together. That is the inverse property of addition. Inverse property of multiplication, on the other hand, now, is where we multiply it times the reciprocal. If we multiply times the reciprocal, we flip it, that will bring us to our identity, which our identity was 1 for multiplying. So 5 times 1/5 equals 1. So when you multiply it times itself flipped upside down, so 1 over 5, you will get back to your identity. You'll get back to 1. Next property, distributive property. The distributive property, if you remember, talks about if I have a number out front of parentheses and there's with a plus or a minus, I can take that a and distribute it and multiply the a times to both the b and the c. So a times b and a times c. So both the b and the c get multiplied times a. So, and it doesn't matter whether there's a plus inside or a minus inside, a times the b and a times the c, both. Okay, so if I have, and if you had all numbers, it works the same too. You can check it this way. If I had 4 plus 2, we know that is 6. 6 plus 5 is 30, right? So if I went 5 times 4, I get 20. 5 times 2 is 10. 20 plus 10 is also 30. And so it works both with numbers and with letters. We commonly do the distributive property in algebra when we're solving for an unknown value. Helps simplify and removes those parentheses from your equation. Multiplication property is 0. For every real number, you can times it by 0. It will equal 0. Anything times 0 is 0. So the name of that property is the multiplication property of 0. So negative 35, doesn't matter if it's negative, positive, doesn't matter. Times it by 0, it will equal 0 every time. Multiplication property for negative 1. Any number multiplied times a negative 1 gets to be the reverse sign. So if I have negative 1 and I multiply it times a negative 5, it'll flip back to a positive 5. If I went negative 1 times a positive 5, it'll equal a negative 5. So it goes back and forth, multiplication property of negative 1. Okay, so what are all these good for? These are good for justifying steps. In other words, why do we do what we do? And so a lot of deductive reasoning is how we logically go from one step to another and give the reason. Why can I do each and every step? Why do I know that this must be true? So looking at this example here, if I start with minus 4b plus 9 plus another b, then there's a few steps I can take, and I can label those steps. Notice, now you got to look close. Looking at this first one over here, minus 4b plus 9 plus b, what did they change to after the equal sign? Well, the only thing that I can see is that there's a 1 here in front of the b when there wasn't before. So what did they do? They multiplied it times 1. That property, why can we do that? Because it's the identity property of multiplication that says you can multiply anything times 1 anytime. It's not going to change the value. Then, from that step, down underneath it, what changed? The minus is there, the 4 there, the b there, the plus there. Then, it looks like the 9 and the 1b switched places. They switch places. Well, what property allows us to switch things in places? That's the commutative property. Which commutative property? Well, we're adding, so commutative property of addition. Next one, they look and we say, okay, we have a b in both places, and now there's parentheses. Much like how we normally distribute b to both of them, we can undo it and use the distributive property that way too. So I'm going to divide out a b from both sides. And so minus 4 plus 1 times parentheses b is the same thing as minusing 4b plus 1b. It's the same exact thing. So that's a distributive property. Last thing, we can just add the minus 4 plus 1. That's just simple addition. So minus 4 plus 1 is negative 3. Tack that onto my b plus 9, and I've simplified this. So that's probably a lot broken down into more steps than we probably would in our brains. In fact, a lot of us kind of know, and we group this into one thing called like terms. But normally when we see a minus 4b and a plus b, we know that they're like terms. We can follow each and every one of these steps, and it'll bring us to the result of minus 4b plus b is a minus 3b. So there's reasons behind everything that we do, and we can break it down step for step for step in very, very small increments So just to prove that what we're doing is right. Look for these. Look for the minute decisions. What changes? How do I know I can do one thing to the other? Look for reasons. The properties that we just went over are the reasons. Thanks a lot. Have a great day.